Same. So the rate at which you are gaining heat from the outside to melt your ice, that's an error, right? Same amount of heat gain from the surrounding. And that's part of our experimental error. Isn't that the extra energy that the ice is using from the surrounding? But tomorrow ki buchhe ekne experimental main problem ta kothay? Problem ta hochhe when you're trying to melt the ice, we're assuming that all the heater's heat goes to the ice. But that's not true though. Where is heat also coming from? From the surrounding. And wouldn't that cause my ice to melt faster than anticipated? Wouldn't that be a problem? So how can I negate that problem? So to negate করার জন্য we use a mathematical trick here. Trickটা হচ্ছে আমরা দুইটা different power-এ experiment করব। So আমার দুইটা different power-এর জন্য এই সব value different আসবে। এটা different আসবে, এটা different আসবে। এইটা খালি কি থাকবে? Same, right? So I'll do the math and show you. So for first 10 minutes, okay? First 10 minutes, what is the math going to be? VIT. Voltage কত ছিল কে বলবা? Table থেকে 0.2, 7.3 into current, 1.8 into time হচ্ছে 60 seconds equals to mass of the ice that melted. So আমরা mass তো মনে বের করছিলাম এখানে. Use the figure to determine the ice melted from 12 to 22 minutes. 65. First 10 minutes, 65, right? Oh, sorry, 600. You're right. So 600 hobe, our mass hoche 65 grams divided by 1000 into latent heat of vaporization, like a fusion, plus ki hobe eta phi. A phi to amra jani na. And the phi is the source of what in this experiment? Error. So let's say you do the math this way. You do the math this way and you'll get an answer. But you will get the answer if you want this value. Ignore this value. And will you get a right answer or a wrong answer? Wrong answer, right? So this becomes what in my experiment? The source of error. We want to do the experiment so that this can be removed somehow. So the way we do this is we repeat the experiment for what? The next ki hobe 12 minutes, right? 10 minutes এর জন্য ছিল আমরা কোথা থেকে স্টার্ট করছি 12 to 22 ও যে এই ম্যাথটা দিয়ে যদি করতে চাও হ্যাঁ আই থিংক দুইটাই করা যাবে বাট এটাই করি নেক্সট 10 minutes তাহলে what's the voltage again for the next 10 minutes ওরা একটা ভ্যালু বলছিল 15.1 into current 3.6 into again 600 should be equal to 140 grams melt হয়েছিল এই টাইমে into latent heat of fusion same থাকবে plus this phi that you see here in theory should also be same because the phi depends on temperature difference and এটা আগেরটার জন্য যা temperature difference এখনো same temperature difference, right? So now we have these two values out there and then what we do here is we subtract one from the other simultaneously যদি equate করো let's say উপর থেকে নিচেরটা যদি মাইনাস করি তাহলে এগুলা সব কি হয়ে যাবে মাইনাস আর এইটা যদি মাইনাস হয়ে যায় উপরটা যদি প্লাস হয় what do they do? Cancel out. And it's a very useful math trick out there. Whenever there's an unknown out there in your equation, right, what you do is you do the experiment in two different values and you subtract them. So the unknown data cancel out, it gets eliminated. So anyways, এখানে হচ্ছে এটা math করলে LF এর একটা value আসবে. So LF should be equal to 15.1 into 3.6 into 600 minus 7.3 into 1.8 into 600. I think that one divided by 140 divided by 1000 minus 65 divided by 1000. এটা করলে যেটা আসে should be the answer. I think so. কত 3.3 into 10 to the power ঠিক আছে ভ্যালুটা I'm not sure that I'll check করব. So this is going to be 330 kilojoules. না আমি ওই বড়টার থেকে ছোট মাইনাস করছি আচ্ছা 3 তাহলে এটা লিখি আমরা 3.3 into 10 to the power 5 তোমরা কি বুঝছো এই টেকনিকটা it's a very common technique by the way. Okay, so টেকনিকটা হচ্ছে কি করতে হয় we repeat the experiment at multiple power ratings assuming that the heat loss for both the rating is what same and once you subtract one from the other in terms of math the unknown gets what here cancelled out cancel out now holo, the net difference is going to be obviously smaller than the absolute value, right? 5 to get to 5, 1 minus 5 is definitely smaller, right? So it's easier that way. Not here. It's different in the experiment I taught you guys. I taught you the one with specific heat capacity. There it was different. And why was it different there? Because when you use more power, your material heats up to a higher temperature. So the loss would be greater. But in this particular experiment, it's not. And the reason behind that is what is the ice at when it's melted? 0. And your surrounding temperature is at what temperature? Same. So wouldn't the difference be same regardless of how fast you melt it? That means the phi must be same. But here's the catch though. I'm just realized for a second mistake ছিল আমার 10 minutes এ করতে হবে. Both of them should be 10 minutes. You can't do one 10 minutes and the other 12 minutes. The reason is that if you do longer duration, within the heat loss change? Because you're waiting for longer time. So you have to make sure you do this experiment for the same interval as well. Okay. Which they guided. I think we're 12 to 22 volts here. Calculate the rate at which thermal energy is transferred from the surrounding to the ice. এটা কেমনে করবো আমরা এখন? এই যে just ও আচ্ছা, তাহলে হচ্ছে in 2000 wait a second, divide by 1000, divide by 1000, তাহলে 330. না যে আমি ডিভাইড বাই 1000 করছিলাম না, এখানে এটা লাগতো না। ওরা চাচ্ছে আনসার ইন গ্রামস, আই থট কিলোগ্রামস যাচ্ছিল। কার কি জানা আছে what the answer is? 330. আচ্ছা ঠিক আছে। Calculate the rate at which thermal energy is transferred from the surrounding to the ice. এটা কেমনে করব আমরা? We're going to take any one of this equation and find what here? The phi, right? So যে ধরো এইখান থেকে নিয়ে আমরা হচ্ছে phi-টা বের করব, and once you know the phi, phi-টা is what? Heat loss to the surrounding. And আমার LF এর ভ্যালুটা কত হবে এখানে? 330 আর 8000 টাও লাগবে না because we're doing the whole math in what? Grams. তাহলে একটা phi পাবা, ওই phi-টাকে কি দিয়ে ডিভাইড করবা? 600. কেন আমাদের ওরা কি চাচ্ছে? রেট কি পাওয়ার না? সো ডিভাইড বাই 600 করতে হবে। সো কি হবে এটা? 7.3 into 1.8 into 600 divided by 65 into 330 কত আসে? ও হ্যাঁ সরি, না মাইনাস, নেগেটিভ আসছে। হ্যাঁ প্রবলেম নাই, নেগেটিভ হবে, লস তো। এটা কি এনার্জি ট্রান্সফার্ড ফ্রম দ্য সারাউন্ডিং টু দি আইস, এটা অ্যাকচুয়ালি এদিকে হওয়ার কথা বিকজ দ্যাটস হোয়াটস হিটিং আপ দি আইস। আচ্ছা রাইট, ফাইটা কিন্তু অ্যাকচুয়ালি লেফটে হওয়ার কথা বিকজ আমি ফাইটা এই সাইডে দিলাম না, রাইট সাইডে থাকা মানে হচ্ছে ইটস লস টু দ্য সারাউন্ডিং, আর লেফট সাইডে থাকা মানে কি ইটস গিভিং দি এনার্জি ইনটু দ্য সিস্টেম। Do you follow what I'm trying to say? It didn't really hamper our initial math because either way it gets cancelled out, but it's actually supposed to be on the other side. Typically, heat loss is a problem because it's losing energy to the surrounding. In this experiment, heat loss is not the problem. What's the problem? Heat gain, because it's gaining heat from the surrounding. তার জন্য একটা equation উল্টা দিকে থাকার কথা। Okay. Because I use 330, that's in grams, and the mass is also in grams. This should cancel out in theory. But I think it's safer to just convert everything into SI and do the math. You never know. Joules just to follow. আচ্ছা, থার্মোফিজিক্স এর কোয়েশ্চেন গুলো বলো আমাকে, আর কোনগুলোতে প্রবলেম তোমাদের? 10. You guys have this book? হ্যাঁ, পুরোটা মেমোরাইজ করতে হবে। আচ্ছা, আমি তোমাদেরকে র্যান্ডমলি জিজ্ঞেস করবো পেজ নাম্বার 55 এর ফোর্থ লাইনে কি আছে। হ্যাঁ না না, if you have to do well you have to follow their method. হ্যাঁ খুঁজে বের করো, মেমোরাইজ করতে হবে, তোমাদের টাস্ক দিচ্ছি। এই রোজার মাসে হচ্ছে প্রত্যেকটা পেজ বসে মুখস্থ করবা, খুঁজে বের করো এটা, নাহলে আমি দিচ্ছি ফটোকপি করে নাও। You don't even follow this book? Oh, তাহলে ওইটা মেমোরাইজ করো। IGCSE? What do you mean? আচ্ছা, আমি এটা বললাম কেন মেমোরাইজ করতে হবে। পেজ 407 এর মধ্যে there is this experiment, যেটা হচ্ছে this experiment. It's basically একটা অ্যালুমিনিয়াম ব্লক নিচ্ছে, ওটার ভিতরে কি রাখতেছে, thermometer and heater, and they're heating that up to find the watt of the aluminum block. হ্যাঁ, আচ্ছা, সো লাস্ট ক্লাসে অনেকে ক্লেম করছিল যে এটা সিলেবাসে নাই নাকি, সেটা জাস্ট কনফার্ম করালাম। ওকে, কোশ্চেন পেপার আসে নাই, বই তো এটা বলছে পাবলিশ 2023 তে, আমি কি করবো? Right, anyways, it's in the book, so you have to memorize the book. That's the punishment. Kunta? so that you don't ask those questions, you know where things are. Okay, so question number 10. During melting, a solid becomes liquid with little or no change in volume. Use kinetic theory to explain why during melting process thermal energy is required, although there is no change in temperature. Who can answer this? Right, but that's just one point. এটা অ্যাপ্রোচটা কেমনে করতে হয়, এই টাইপের কোয়েশ্চন আমি বলি, you should look for that equation of internal energy. What is the equation? Del U equals to del del U U equals to sum of random K plus potential energy. The thing you need to remember here is that this thing will only change if there's a change in what? Temperature. And this will only change if there's a change in what? Right, so একটা state change যদি হয় তাহলে এটা হবে, and then you narrate that. So এখানে যেটা বলছে, using the theory explained in melting process কি হয়, so first thing you say in melting process, what remains constant? Temperature, right? ওই বলছে না, although there is no change in temperature, so that means তোমার হচ্ছে temperature constant, which means there is no change in K. However, during melting process, aren't you still providing energy? So তুমি যদি energy দিয়ে থাকো আর এটা যদি না change হয়ে থাকে, where might the energy go? Potential energy. And whenever potential energy is gained by a state, the particles move apart. Because the মাঝখানে imagine করে একটা spring আছে, ওই spring এর মধ্যে যে এনার্জিটা, that's called potential energy, chemical potential energy. So as you start to stretch them, it's like a spring being stretched. What happens to the potential energy when you stretch springs? Increases, right? Similarly, and that's why whenever you take the particles further apart, energy is needed to separate them, and that's that energy in the potential energy. Okay, so first point লিখবা হচ্ছে energy is provided, মানে তুমি energy কিন্তু দিয়ে যাচ্ছ, that's the important part. However, change in temperature is constant, which means what is constant? K is constant. And then you say that means P must increase, and P increase মানে হচ্ছে separation কি হচ্ছে increases, which is change in state. So I think হ্যাঁ, ওইটা হচ্ছে এখানে হবে, potential energy হচ্ছে increase হচ্ছে because work is done, আমি একটু লিখে দিই, work done to move the particles to bigger separation or larger separation. Work done টা লেখো, because ওই যে আরেকটা কোয়েশ্চেন আছে যে কেন হচ্ছে মেল্টিং এর থেকে বয়লিনে the energy needed is much higher. So তখন there's an additional work done. What was that? The atmosphere, right? You have to push the atmosphere out, that's why extra energy is needed. Okay. No work done. কি বলো বা? Oh, acha buchhi. Okay, too different. I'll explain. Acha, there's a point here in the Mars scheme. That's actually a different approach. Are these points there? What's the? Can you tell me the answer? right? Nothing to say about KE. Because ওরা যেটা ইউজ করছে ওরা এটা ইউজ করছে del U equals to del Q plus del W, and the del Q here is what energy? Thermal, and this is internal, and this is work done. In this particular scenario, the change in state, is it because you're doing work on the system or doing work against the system? No, right? You're providing thermal. So I think they're emphasizing on the thermal energy being required. I took the question on focus on this. There's no change in temperature, right? I don't think so, because explain why during melting process thermal energy is required, although there is no change in temperature. The answer doesn't acknowledge why change in temperature is not there. So I feel like what a ball out. Law of the using ideas of laws of thermodynamics. It is as a thermodynamic equation. First law of thermodynamics, right? Kinetic theory is this one. The energy in matter is based on sum of random K plus potential energy. And yeah, I'm surprised actually. I mean, it still doesn't really make sense. Multiple questions. Direction of the question এটা হচ্ছে আচ্ছা let me give you my argument here against their case. আচ্ছা ওরা বলছে use kinetic theory of kinetic theory কি এটা একটু ক্লারিফাই করি আগে আমরা. What's the kinetic theory of matter? That temperature is directly proportional to the average KE of particles. That's the kinetic theory of matter, the first theory that you learn in chemistry grade 9 that temperature বাড়লে average kinetic energy বাড়ে. ওটাই কিন্তু kinetic theory of matter. আমরা A level এসে we gave it a new direction. We said that it's not only K, but there's also what involved here, potential energy. And for gases, the potential energy is not there. That's why তোমরা যে kinetic theory আগে করে আসছো O levels, it was only for what? Gases. It was the ideal gas laws, the Boyle's law, Charles' law, and the pressure law, right? So that's the law. So that would mean that I have to take this into account, right? Now, this equation is a different theory out there. What is this theory called? First law of thermodynamics. First law of thermodynamics says that any change in internal energy is only attributed to either a change in what? Thermal, or a change in what? Work done. So I feel like this should be the better way. Okay. তোমার answer B তে problem ছিল. Okay. Aluminium of mass 160 gram contains 330 grams of warm water at temperature 38, illustrated here. The mass of 48 gram of ice at minus 18 is taken from the freezer and put into water. Right. The ice melts and the temperature of the can and its contents is 23 degrees Celsius. The data from specific is given here. Assuming no energy to the surrounding, show that loss of thermal energy of the can is that. Use information to find the value of that. Acha, okay. এটা কেমনে করতে হয় একটু বলি. It's one of those questions on the practice এর জন্য বলছিলাম মানে ক্লাসে করাইছিলাম. The best way to solve these questions is to actually draw what for this? A graph, and I'll tell you why. It's easier to picture কি হচ্ছে. So এখানে you have time, seconds. Mass of 48 gram of ice is at minus 18 degrees Celsius. So you start at what temperature here? Minus 18. এটা দেখাতে হবে না, but it's useful. Okay, মানে তোমাকে picture করার জন্য কি হচ্ছে. And then put into the water. The ice melts and the final temperature of the can is this. So ice melt করে what's the final temperature of the ice as well? 23. No, 23 final টা. So এটা কি করছে? এখানে গেল, তারপর কি করছে? Melt করছে, তারপর এখানে গেল. So what's the temperature at the top? 23. So that's all that happened here. But this ice gained this energy entirely from what? The warm water, right? Warm water was at what temperature to begin with? 38 degrees Celsius. It cooled down, and came and met at what temperature? 23 as well. So there are two things happening here. There's a cooling, like there's a system that's actually losing heat. That's the warm water. And there's a system that's what? Gaining heat. What is that? Ice. In theory, ওরা বলছে, আমি বলতেছি না, ওরা বলছে that assuming no energy to the surrounding, the energy that is gained and the energy that is lost must be what? Equal. Aluminium can. হ্যাঁ, that's true. Sorry, এখানে হচ্ছে দুইটা পার্ট আছে। অ্যালুমিনিয়াম ক্যানটা আছে। অ্যালুমিনিয়াম ক্যানের ইনিশিয়াল টেম্পারেচার কি ছিল? 38, right? Yeah, it should be 38. না, করতেছি মনে হয়। এই যে show the loss of thermal energy of the can. আচ্ছা দাঁড়াও, একটু দেখি না ওরা কি ইনফরমেশন বলছে। But you know, if your aluminum can is this mass and warm water at that temperature, I think the can should be also 38 degrees Celsius. That makes sense. What will happen here? The aluminum can is going to lose energy, and what else is going to lose energy here? The water, right? So there are two sources from where the heat is coming. আচ্ছা, আমরা কোয়েশ্চেনটা অ্যাপ্রোচ করি। Show that the loss in thermal energy of the can and the warm water is that. আচ্ছা, they're considering it together as one object. So কেমনে বের করবো এটা? কি হ্যাঁ, so let's write the statement here. কি হবে? Thermal energy lost by what? By water and can must be equal to what? Thermal energy gained by what? Ice, right? Thermal gained by ice. Right. So what's the thermal energy gained by ice? I think gained by ice is very easier. Or male জানি না তো, right? We know specific capacity of aluminum and water. Oh, আলাদা করে করলেই হয়ে যায়. Yeah. So what we do here is mc del T for what? Aluminum plus কি হবে এটা? mc del T for water. That's it, right? So what's the mass of the can? Do you know the mass of the can? Oh, acha. Can 160 ছিল, right? Tell they need the can to be included. So divided by 1000 into specific capacity কি grams এ দাও or not? Grams এ দাও, sorry. তাহলে এটা একটা জিনিস করে Cambridge. I don't know why they keep every values here of specific capacity in grams, but it's typically something you have to be aware of. So 0.910 into change in temperature কত হবে? 38 minus 23. Equal to না, plus mass হচ্ছে 330 into water কি 4.2, 4.18. 4.18 into again how much? 38 minus 23. This will give you the total energy that was brought to the ice from the surrounding, the can. Oh, whenever we take the change, we take the absolute higher value. So that means it's always the higher value minus the lower value, not final minus initial. It's always high minus low. Yeah. কত আসে এটা? 22875 joules. আচ্ছা, ওরা শো করতে বলছে। So yeah, approximately 2.3 into 10 to the power 4. 1, 2, 3, 4 hand. Use the information to calculate the latent heat of specific latent heat of fusion for ice. So how do you do this? No. হ্যাঁ, মানে এখানে তো থার্মাল এনার্জি ইন ইজ হাউ মাচ? 22875, বাট ওটা কোথায় যাচ্ছে? Yes, exactly. mc del T plus ml plus আবার কি mc del T, because there's a heating in the ice form, there's a heating in the liquid form, and there's a what in between, melting. That's why I recommend যে এই গ্রাফটা থাকলে ইজিয়ার হয়। এই গ্রাফে দেখো তিনটা জিনিস হচ্ছে, so that will be easier, right? এখানে হচ্ছে mass is going to be 3 কত 28, no 48 divided by 1000 না করি এখানে specific capacity 42 mass of ice, right? এখানে হচ্ছে 2.10. So do we know the specific capacity of ice হচ্ছে 2.1? Our water. Oh, sorry. So 2.1 into what's the change in temperature going to be here? 18. 18 minus 0 plus m হচ্ছে again 48 into L plus 48 into 4.18 into কত হবে এটা? 23 minus 0. So this is 22875. So এখান থেকে L যেটা আসে should be the answer. 350. Are you clear তোমাদের? Three B2. 5 years. Are you clear? 3B2, 3B2. আচ্ছা এটা এটা পরে করবো ওই গ্যাস লজ এর কোশ্চেন গুলো সো জাস্ট থার্মাল গুলো করে নিয়ে আমি গ্যাস লজ আজকেই স্টার্ট করবো ইউর ওয়ান ইজ অলসো গ্যাস ল 5B no not gas law the balloon bursts when thermal energy leaves and enters the gas ওটা আচ্ছা এটা দেখো 5 by reference to first they actually mentioned that very clearly here I hope they stick to it by reference to first law of thermodynamics state and explain the change if any to the internal energy of a lump of solid lead as it melts at constant temperature so এটা যেটা করবা first হচ্ছে ইকুয়েশনটা লিখে নিবা del u equals to del q plus del w and also you have to constant temperature to bolche you need to also relate to which equation here the del u is broken down into what sum of k plus potential energy acha ekhon bolche a lump of solid lead as it melts at constant temperature state and explain the change if any in the internal energy what do you think internal energy kono change hoy na ki for a lump of solid lead that melts yes কারণ হচ্ছে otherwise কেন মেল করবে right so internal energy কি বাড়ে না কমে বাড়ে so I'll show you what to do here and then I'll teach you how to write the answer okay so এটা বাড়ে but it's at what temperature constant temperature which means the kinetic energy is what here constant এখন কোয়েশ্চনটা হচ্ছে যে ওরা কেমনে মেল করতেছে এটা কিছু বলে নাই constant temperature so there's a small issue here. Issue we don't know the process of melting. You can melt a solid in two different ways. What are the two different ways? By heating it, and there's another famous way of melting it. What is it? Friction the hoy. Yeah, by passing current. Current pass kole things smell like the fuse or wire to hoy কাজ করে, right? So যদি হচ্ছে আমি বলি যদি এটা হিট করে মেল্ট করা হয়তো কোনটা বাড়তো রাইট আর যদি হচ্ছে তোমার ইলেকট্রিসিটি দিয়ে মেল্ট করা হয়তো W because electrical work done is that right so one of the other with the but I think they're not looking into this equation they're more focusing on that one here which is strange because they ask for what first law of thermodynamics yeah on the left equation but আমরা ওটি কোয়েশ্চনটা how do we know it's heated না তোমরা আমাকে একটু বলো যে how are you guys sure that it's been heated ওটা তো absorbing temperature এটা নতুন শুনছি কি এটা absorbing temperature আচ্ছা আচ্ছা maybe check আচ্ছা before I check আমরা যদি পাশে ইকুয়েশনটাতে লিখি কি লিখবো it's a constant temperature so therefore what must remain constant k and potential energy must change and potential energy is been changed because what's been provided to it heat thermal energy, right? বলো হ্যাঁ বলো decreasing. No, it's a lump of solid that melts. Solid, when it goes from solid to liquid, volume increases because it's melting. আচ্ছা আমি তাও দেখিনি এটা মে জুন 20. হ্যাঁ, but ওই যে প্রবলেম হচ্ছে যে my line of answer would be based on whether it's been heated or work been done. Q বা W একটা তো চুজ করতে হবে, ওইটাই বুঝতে হবে। আচ্ছা একটু এদিকে দেখি না, আই থিঙ্ক কোয়েশ্চেনে কিছু মিসিং নাকি ওটা চেক করি। Okay, so to clarify, Corey, the answer they gave is based on the assumption that your piece of lead is being what here? Heated. So if you heat your piece of lead here, thermally, so you're providing what here? W or Q? Q. So Q বাড়তেছে আর এইটাকে যখন মেল্ট করা হচ্ছে, are you doing work on it? No, right? So are you like changing shape? Are you compressing it? Are you stretching it? No. তাহলে আমার W কি থাকবে? Constant. And that's the reason why there's a change in state as heat has been provided. The heat that's been provided is used to what? Change the state or break the bonds or take them further apart. So when it goes from solid to liquid, we consider it to be negligible, and that's always in the mark scheme. Whenever these melting process comes along, they write in bracket little or no change. Little is there because there's actually some change, but when it goes from liquid to gas, it's substantial. Oh yeah, just they assume there's little change in volume because the change in state is not that big from solid to liquid, but from do you assume that there is no change in volume, right? Because there's no work done on the system or by the system at that point. না ওরা এটাই ইউজ করছে, আমি বলি এটাই ইউজ করতাম আমি। আমার এখানে কোয়েশ্চেন ছিল যে ডেল কিউ যেটা এটা একটা হিটিং প্রসেস, আর ডেল ডব্লিউ কি ওয়ার্ক ডান। মেল্ট করা যায় দুইভাবে, কারেন্ট দিয়ে বা হিট করে, আমরা জানি না কোনটা। তো এখানে ওরা অ্যাজিউম করছে হিটই করা হচ্ছে, আর কিছু না। না কারেন্ট করতেছে না, বলো। evaporates, decreases because evaporation, এটা তোমার সিলেবাস, এটা একটু আগের কোশ্চেন, সিলেবাসে একটা টপিক ছিল on evaporation leads to decrease in kinetic energy of the particles because the more energetic particles escape from the surface. Answer that as it is. Internal energy, impossible. Evaporation internal energy increase on evaporation is a cooling effect. It's a very common question. So cooling effect কি হয়, k টা কমে যায়। হ্যাঁ দেখো তো। আচ্ছা, some gas in a toy balloon, when the balloon bursts and no thermal energy enters or leaves the gas. আচ্ছা এটা একটু স্ট্রেট ফরওয়ার্ড হবে, সবাই একটু দেখো এদিকে, কথা না। So you have this balloon that bursts. Balloon যখন burst করে, what does the gas do? The gas is compressed right now and it expands. So আমরা যদি এই ফর্মুলাটাতে যাই, del u equals to del q plus del w, what is happening to the work done here? Is it plus or minus? Minus, because it's expanding, right? So minus, since work done by the gas. তো ওরা জিজ্ঞেস করছে what happens to the internal energy? It decreases here. আচ্ছা, and এটা তোমরা নোটিস করবা যে কোনো সময় কোনো একটা বেলুন বার্স্ট করে, বেলুনটা যদি ধরো, it's actually cold. balloon burst করার পর যদি ধরো দেখো it's always slightly cooler. কেন? Because the energy was taken away from the gas to expand, and that's why the gas cools down. Okay, so you find that this decreases. Clear? Of 4C. It's clear. Yeah, it I get it. Adin, paisa. Acha, for the first one, you'll say that there is an increase in internal energy. Question. So, acha, bolo. Summer 23. Variant 42. For Siebel's, is it thermophysics? তোমাদের কি winter 23? We did that in class. Yeah, and the lamination, the eddy current. Oh, it's actually AC current related. No, it doesn't, but it's there. You'll find a lot of questions in the past paper. Variant 42. Question number? A sample of water when it evaporates from a rain puddle on a hot day. What happens to the internal energy? Sample of water when it evaporates from a rain puddle on a hot day. What happens to the internal energy of a sample of water? That was just a question. Right. So, actually, the question is different. They're asking what happens to the internal energy of the water that evaporates. The water that evaporates has what internal energy? Higher. And the puddle that's left behind has what internal energy? Lower. So, iter answer for this particular one will be higher. Can higher have it? Because Ora can question about that the water that's heated during a summer day, hot day. So, water that evaporate, what does it gain? Thermal energy, and it what increases? Internal energy, and the kinetic energy increases, and then it escapes. So we water যেটা escape করতেছে ওটা কথা বলতেছে, but যে puddleটা আছে আমি puddleর কথা বলতেছিলাম, ওই puddleটার থেকে তো এই energetic particle টা চলে গেল. So what happens to the internal energy of the puddle? Bonds. Potential energy work is done because it has to move itself out. So potential energy changes. It's not melting or boiling. মনে আছে ও লেভেলস ছিল evaporation and boiling দুটো আলাদা প্রসেস, কারণ এটা ওই সেম ভাবে কাজ করে না। So it's just one particle escaping, not all of them. Just K টা এত হয়ে যাচ্ছে, it can escape. 4C. আচ্ছা, এটা একটু দেখো, আমি অ্যানসার গুলো লিখে দিব, আগে একটু ডিসকাস করে নেই সবাই স্ক্রিনে। এই লাস্ট পার্টটা, state and explain the change, if any, in the internal energy of a solid metal ball as it falls under gravity in a vacuum. So if something is falling under gravity in vacuum, there's no thermal energy provided because there's no what involved, friction, air resistance. তাহলে এখানে হচ্ছে আমার হচ্ছে thermal energy দেওয়া হচ্ছে না, but what is changing though? No change. Yes. You know why they give this question? It's a very old question. Eta mone abar repeat korche. Eta that because everyone knows that when something is falling, what is it losing? Gravitational potential energy. Tora ki kore ekhane likhe fele je the ball is falling, so the potential energy is changing. But amader je chapter ta doesn't deal with the potential energy of the object. What are we dealing with? Potential energy of the particles inside. Ota kono change hocche na. Like a ball jokhon porteche, the only way you can change it is either by heating it or by what? Work done. Konta hocche ekhane? However, if it fell in air, there will be changes. Yeah, because there's work done against air resistance, and as a consequence, the internal energy increases, and because of that kinetic energy of the particles increases. Potential energy changes because the ball is not going to melt. That will probably be true for an asteroid. The potential vaporizes, right? We can know it, not in this case. Okay, are you clear? What did you write, or what did you think initially? Oh, so the gravitational work done. Yeah. Well, we are focusing on the particles.
I tried to go through the marks and still I didn't understand the marks.
This which one was it? This value, right? Use oh, this one. It's a PLP one. Like ask you to use you got this one, right? Watch, I thought you were looking for this one. Okay, explain whether the potential is higher at the end of this or not. It's rotating in which direction? Clockwise. This way. Magnetic field is which way, do you know? Right. So if your magnetic flux is into the page and this movement is down, right, force. We have to use the right hand. Why? Because this is a dynamo. You can't use the left hand. Left hand is used for motor activity. It's not motor activity. It's the dynamo activity. Because this EMF induction, right? SVI. Right. So your EMF is going to be this from A to X. This end. The answer is A, right? Higher potential X. Right, so let me see what's happening here. So you have the spoke here. And it's spinning this way, and your magnetic flux is into the page, right? So if you use your left-hand rule, can you tell me which way is the current flowing? Use your right-hand rule. Force is downwards. Magnetic flux is into the page. Which way do you think your force is? Your current is flowing? passes into the page, forces downward, right? Which was current flow. FBI. P is into the page, forces which were downward. So isn't my finger pointing that way? So it's actually going from A to X. Okay, so A is positive, X is negative. But what's happening is that the charges will start to flow. And as the charges start to flow here, because there's a EMF generated here, as the charges start to flow here, the charges will come and stop here. And this place will now have more charge compared to there. So the charges will all move out from the center and they'll end up at the other edge here. So that's why the potential will be higher here. That's one way of answering it. The easier way, I feel, is that this thing is rotating, right? Where is it the fastest? So it's cutting the field lines at the greatest rate. So what's the EMF be there? The highest. That's the easier way, but they ask for lenses. For lenses now, you need to talk about this. That the charges will move the other direction to oppose the motion. And that's where there'll be more charges. Okay, take out your book two. Book two paper. Okay, we'll start work power energy. Okay, let's start. Shall I just screen it? Let me explain this topic. So, as I told you, it's actually a very elaborate topic, but they broke it down into chunks. So you have energy resources and energy transfers. So within energy resource, you have the different types of energies out there. So I'll do an exercise to make you familiar with that. Recent years, they changed the format. So now you need to learn the different stores and the different modes of transfer out there. I'll teach you how to figure that out. Then you need to understand the principle of conservation of energy. The syllabus translates to how GP gets converted to KE and vice versa. Basically that idea. Then you have efficiency, Sankey diagram. And then this one part here, it's your conduction, convection, radiation. Okay? But Tarakde will be doing work done. So work done and under, you'll see what KE is, gravitational potential energy is, and the formula for power. And then at the end, we'll wrap up the chapter by doing this. It's called energy resources. Like the different types of energy resources out there and their advantages, disadvantages, and everything. This is very popular in the recent papers, 6-mark question. And they'll give you 2 different energy resources and they'll ask you to compare their advantage, disadvantages. Okay, so yeah, that's the chapter. Once I'm done with that, I'll come back to this conduction, convection, radiation. Okay, that'll be the end of the topic. So yeah, আজকে যেটা করব is very easy. I think most of you should be able to answer right away, but I'll be using this to teach you something. So আগে দেখতে চাই তোমরা কতটুকু পারো। So এটা হচ্ছে energy types and conversion. So what I'll do is I'll give you, and it's there in your book. I think there are 20 of them, 19 এখানে, 19 different scenarios out there. And তোমাদের যেটা জানতে হবে or figure out করতে হবে যে what are the energy changes taking place in each of them. Before we start, you need to understand there's a law that applies to explain this. It's called the law of conservation of energy. What does the law of conservation of energy state? Right, energy can neither be created. Energy is neither created nor what? Right. তাহলে হয়টা কি? It only gets transferred from one form to another, okay? It only transfers from one state to another. It's the most fundamental law of thermodynamics or energy. It is so fundamental that এটাকে first law বলা হতো. They changed the name. It's not called first law anymore. It's called the zeroth law of thermodynamics. And it is that basic. Okay, so first law is something else. এটাকে বলা হয় the zeroth law of thermodynamics. It's the foundation of everything in the universe. We have to make this assumption to, come up with anything that we do out there. That energy can neither be created nor be destroyed. It can only change state. Starting from your black holes to quantum, physics, wave particle duality, whatever you do, right? A law take maintain করতে হয়. If we come across any law that doesn't satisfy with this or agree with this, that law can't exist. So this is a very fundamental law there. So I'm gonna just start with this, so it's not that complicated. So yeah, you need to learn. Tell me the different energy transfers that take place for a lamp running on a battery, a fan, a microphone, loudspeaker, এগুলা আমরা পাঁচটা করে করব. আমি একটা করে তোমাদেরকে দেখাই কেমনে আমি চাই অ্যানসারটা. আচ্ছা, so what is the energy transfer for a lamp running on a battery? So first of all, you need to understand input কি এখানে and output কি এখানে. So it runs on a battery. A battery has a certain kind of energy stored in it. Does anyone know what? Right. So তোমাদের একটু general knowledge লাগবে for all of these scenarios. So this is a lead acid battery. It'll be the lead acid and there's sulfuric acid. And when the sulfuric acid and lead interact, it produces electrical energy, and it comes from the chemical bond stored inside it. So where does the energy come from? The chemical inside, right? So the battery possesses chemical energy, but then it's given out as what? It's given out as light, right? Light is the output. So you have light that's coming out from here. And what is the input here? Chemical. However, how did this transfer take place? From the chemical to the light, it transferred to kemne hocche. So here is an interesting thing. Some of the energy transfers that we'll be learning, right? They're basically an intermediate branch. Let me explain, okay? So তোমাদের syllabus there are 4 transfer mechanisms out there. You have to learn this. This is a new syllabus thing. 2019 থেকে পাবা, 2019 এর আগে question paper এটা ছিল না. So 2019 থেকে there are 4 transfer mechanisms out there. But if I want to transfer energy from one state to another, what is the mechanism out there? So number 1 is mechanical. Mechanical মানে হচ্ছে any energy transfer that involves what? A force. So force যদি দিয়ে কোনো energy transfer করতে পারো, it's called mechanical. Let me give you an example, okay? You throw a ball. When you throw a ball, what do you apply to the ball? A force. And the ball gains what energy? Kinetic energy. So the ball gains kinetic energy by what transfer? Mechanical, right? At a gari brake করতেছে, brake করার জন্য the car brakes will what onto the tire? Push onto the tire. What does it apply? Force. So anytime there's force involved, it's called mechanical energy transfer. Okay. So if you bend something, it's mechanical. If you push something, it's mechanical. You stretch, you compress. Anything that has force involved is called mechanical. That's the first transfer mechanism. That's what we use mostly in our day-to-day life, right? Second mechanism is electrical. So electrical is could be interesting. You have done the electricity chapter. Electricity on its own, right, is useless. But if there's electricity out there, right, it's pointless. What are you going to do with it? It's only useful if you can use that electrical energy to do what? Something, light something, move something, run something, right? So electrical energy can be a transfer mechanism. On its own, it is pointless. For purpose, it's like a lightning striker motor, which is also useful because there's light and heat there. But there's a very important need for it. Let me explain. This electrical energy is so useful. There's what inside this battery? Chemicals, right? Key chemical, namely lead and sulfuric acid. And then let's say I take electrical appliance here. It's a light, a laser, right? এখন এটার দরকার হচ্ছে এনার্জি টু রান, chemically there's energy to provide. If I take my lead and acid and pour it on this, right, will the lamp glow? Cannot. Let's say there's a reaction taking place, the lead and the, so I coat this with lead and then I pour sulfuric acid there. It will react, right? But will the lamp glow? Why not? Transfer to what energy? Light energy to যাচ্ছে না, কেন যাচ্ছে না? Very good. So electrical energy is a translator. Translator মানে কি? You have this chemical energy which speaks the chemical language, right? And you have this lamp here that only understands what? Electrical language. তো ওকে যদি ওকে এনার্জি দিতে হয়, মাঝখানে আমাকে এরকম একটা ফর্মে ট্রান্সফার করে দিতে হবে that the light can what? Recognize that. What is the energy that the light recognizes? Electrical. What's the energy that the chemical can transfer itself into? Electrical. So basically the electrical energy bridges the what between these two? Gap, right? It's basically a bridge between the two energy sources. So on its own, electricity can be pointless, but it's very useful because a lot of appliances recognize what energy? Electrical energy. And a lot of systems out there also produce what energy? Electrical energy. So wouldn't that be a good setup? That you take energy from other sources, make it into electrical, transfer it very easily, and give it to appliances that understand electrical. So electrical transfer to shopke useful, like everything runs around us because of that. It's very easy to transfer. Start without it, right? It is continuous. It can carry a lot of energy out there, and everything in this room has been designed so that it recognizes which energy, electrical energy. Okay, and we have devices out there somewhere that's producing what energy as well? Electrical energy, like a generator. Generator electricity produced for you, right? So electrical is the most useful transfer mechanism out there. Then we have thermally, and thermal to tomra pore shikba. তোমাদের there's a chapter called solid liquids and gases later on. আচ্ছা, ওই chapter মধ্যে there's thermal physics, specific heat capacity and all that, right? ওইখানে we'll learn that if I want to heat something, when I want to increase the temperature of this, there's only one effective way out there. I take something with a what temperature? Higher temperature, and I bring it in what with that object on that. তাহলে the energy would be transferred from the higher temperature to the lower temperature. এই mechanism থেকে thermal energy transfer বলা হয়, and that's what you typically would call as heat. The heat যখন করা হয়, what are you actually doing? You're taking something cold and placing it on something what? Hot, and that's what flames are for. So just তোমরা যখন flame use করো, what does a flame do actually? So flame যেটা হয় is you have a flame, right? Flame tells you temperature 400 degrees Celsius. You take your cooking pan and you place your cooking pan on the flame, right? What is transferred from the flame to the cooking pan? Thermal energy. Heat word আমরা use করবো না, চেষ্টা করবো না use করতে, because it's actually not appropriate. A levels again, you'll have to like completely forget the word heat. So it's actually thermal and internal. There are two words out there. I've written that on the top. Like, thermal is when energy is given out, and internal is when the energy is taken in. So I'll explain that with examples. Right. So thermal te kemne hoy, so if I touch the wall right now, there's energy transfer going on. Thermal. Ke kake diche? What do you think? Yeah, hand to wall, because my hand is warmer than the wall, right? So that's thermal energy transfer. কিছুক্ষণ পরে আমি যদি এই হাত দিয়ে ধরি, এই জায়গাটা is warmer. So I have transferred energy out there, right? It's called thermal energy transfer. Thermal energy transfer যদি আর একটু clarify করি, it's conduction. Remember conduction, দুইটা object contact আসলে energy transfer হয়, that conduction, okay? Convection is not thermal energy transfer. Radiation is not thermal energy transfer. It's only conduction. So what are the four transfers out there? Mechanical, electrical, thermal, and the last one, তোমাদের syllabus একটু different নামে দেয়, is basically waves. Any wave, light, sound, right? তার জন্য radiation is actually a what energy transfer? A wave energy transfer, because I don't know if you know this, radiation is what wave? Infrared. So there's a wave called infrared radiation, right? So the wave course, right? So infrared radiation is basically wave, right? So yeah, your thermal radiation is your wave. So the point I'm trying to make here, there are only four energy transfers out there in the universe. You have your mechanical, electrical, thermal, and waves. Okay, তোমাদের সিলেবাসে ওয়েভের জায়গায় লিখতে খালি হচ্ছে radiation and sound. So অনেকে কনফিউজ হয়ে যায়, তার মানে কি খালি radiation and sound? No, every wave is a mechanism of energy transfer. But here is a problem though. এই যে আমরা যে microwave transfer করতেছি এই রুমের ভিতরে using our router, right? Is it transferring energy? The microwaves that we use in our Wi-Fi router, right? ওরা কি energy transfer করে? So the answer is no. They actually transfer information. And that information is carried through waves that have energy in them, but the energy is not the main purpose for them. What's their main purpose? To transfer information, right? So একটা cell tower যেটা থাকে, right? যেগুলো হচ্ছে cell phone network tower use করা হয়. They're sending out thousands of different waves every second out there. Are they heating up the environment? Not really. কারণ ওরা খুব small amount of energy use করে, but what do they carry with them? A lot of information. Okay, so yeah, তোমাদের syllabus radiation and sound can mention করছে. I understand their logic because those are the energy transfer mechanisms out there. Sound the energy transfer হয়, are radiation to radiation, right? So if you remember the electromagnetic spectrum, what was the first one? Radio waves. Does it do anything? No. Microwave, does it heat something? Yes, but a very specific one that's designed for that specific purpose. The one we use where? In the microwave oven. What does it do? It excites the water molecules, right? So it's different yellow. Infrared, does it transfer heat? Yes, it is the one that we feel as the most energetic energy out there in terms of radiation. Something heat visible light is one of them as well. Ultraviolet. Okay, 18 together is what we perceive as the energy coming from the sun. Ultraviolet doesn't actually heat anything. So ultraviolet you can shine right? Like a little high dose of it, you wouldn't really feel any warmth. You wouldn't feel anything changing, except for the fact you are getting higher chances of getting what? Skin cancer. That's it. So you wouldn't really feel it. So ultraviolet light they don't feel it. Lighter under gele, do you feel the warmth of it? Sometimes. Do you know why? Light ki heat করার কথা things. এই laserটা, right? এই laserটা হচ্ছে আমি যদি নেই এখন and I pointed at, let's say, a point on the wall, right? Like let's say there. Sorry. তোমাদের এই জায়গাটা কি হচ্ছে গরম হয়ে যাবে? In theory it shouldn't. Light doesn't heat things. So এটা গরম হয় actually. কেন হয় জানো? It's because এই লাইটের সাথে partially কি রিলিজ হচ্ছে? Infrared radiation, and that's the reason why it heats up. তার জন্য এই filament lamp গুলো কাছে গেলে অনেক গরম ফিল করা যায় because they're giving out a lot of watt with them. Infrared. LED তে infrared অনেক কম থাকে, so you don't really feel the heat out there. It's a different stuff. So light on its own is not actually an energy transfer mechanism. It's just infrared. That's why we use the term radiation. Okay. Right. So those are the four. Sorry. Oh, they heat up. The bulb itself heats up, so they release the radiation of infrared as well. Same with the filament lamp. The filament lamp is giving light, right? But where is the infrared coming from? From the fact that the filament lamp has what temperature? Like 5,000 Kelvin temperature. Infrared. Good question. So the bulb has two layers here. One is the filament inside, and or in this case, the circuit. And on the outside, there's a glass out there. So